Hello and welcome back to What Exactly. In the previous video, we discussed about positional encodings and transformer networks overview. In this video, we are going to discuss something which is called masking and the type of masks, which are look ahead mask and padding masks. First, let us discuss about padding masks. So, what is masking? Before getting to know about masking, let us understand padding. Suppose you have series of numbers like 1, 2, 3, 4 and 2, 3, 5, 6, 7. As I already told you, these number represents a word like he is a student. He is a good student. Let us assume these are the two statements, okay? So the length of this and this is different. Here the length was 4 and here the length was 5. As I already told you, transformer network accepts parallel way of data. So we are giving data parallelly. So the data must be of fixed length because they cannot accept variable length. The model should priorly know how much is the length of the data. So that is called maximum sequence length. So for our model, we are inputting the maximum sequence length, which is the maximum possible length of a word. Sorry, a sentence. So how can we achieve this? See, here we have 1, 2, 3, and 4. We cannot randomly add garbage values because it will affect our model performance, right? So what they usually do is they add zeros at the end. But when we are adding zeros, this will affect the model performance. So instead of adding zeros, we mask zeros. So what is masking zero? Suppose you have this number and assume that our maximum sequence length is 10. So our sentence will be encoded this way 1, 2, 3, 4 followed by 6 zeros, right? So our model only should need to learn 1 and 1, 2, 3, 4 these sentences. So all these values are garbage values. So it is not necessary. This is not responsible for loss function or our accuracy, right? So what we do is we mask these numbers. So this is a rough overview of masking. I'll be showing you how to do masking, okay? Okay. As I told you in the previous example, we'll be masking 1, 2, 3, 4 followed by zeros. But when we are sending this to an activation function, we'll get some value. So in order to avoid this, in order to avoid zeros affecting our loss function and our accuracy, we instead of adding zeros, we add 1e minus 9 or 1e minus 6. So whenever we are doing softmax of this number, like negative, let us assume it is negative infinity, we will get 0. So this will affect very less in our loss function. So that's why we mask these numbers. So what is masking? Initially, you have padded the sentence like 1, 2, 3, 4, 0, 0, 0, 0, 0, 0. What we do is we send it to a function, and what it does is it will replace all the zeros with negative infinity. In our case, we can take it as 1e minus 6 or 1e minus 9. It's of your wish. So it will mask it to negative infinity. So our values will become 1, 2, 3, 4, 1e minus 6, 1e minus 6, 1e minus 6, and so on. So whenever you are doing softmax of this number, this will not affect our result. So this is about padding mask. Let me erase all this stuff. Let me show you this padding mask using an example which we take as embeddings. Let us take x1, x2, x3, x4 as our embeddings, and let us assume that our maximum sequence length will be 5. So this is x5. Okay, as I already told you, we are masking these numbers. So what our mask function returns, it will return 0, 0, 0, 0, and whenever there is a mask, like whenever there is 0, it will return 1. Okay, this is our mask function. So here we will be having query key and value pair, query key and value pair, query key and value pair, and so on, value pair. Okay, so you are calculating an embedding vector using these query key and value pair. So whenever we encounter mask as 1, this will not be responsible in calculating the embedding vector. So this is the significance of padding mask. And we will be passing this padding mask into the stack of encoders also. Why we are passing? See, this is the same architecture implemented in the encoder layer also. This is input layer encoder, and we'll be having n encoder layers, right? The same thing happens. So we are ignoring the query key and value pairs of fifth vector. So whenever there is one, we are ignoring it. That's what we follow here. So in the same encoder layers, we will ignore the query key and value pairs which come from fifth vector. This is about padding mask. The next will be look ahead mask. Let me clear all the ink in the slide. Okay, before getting started, let me tell you the significance of look ahead mask. So if you have numbers 1, 2, 3, okay, let me take it as x1, x2, x3, and x4. Let me take x5 also. x5 to be 0, okay. So in encoder layer, we'll be having query key and value, query key and value, and so on. So in order to calculate the embedding, we will be using query key and value pair from each and every sequence. See, at every timestamp, we are using query key and value pair. But whenever you are in a decoder, see, our decoder will predict one output at a time. So it do not have knowledge of the future predictions, right? See, if you are writing I am a student, in an encoder layer, you are giving I am a student at the same time. But in decoder, when it is converting, suppose it is converting into Telugu, like in Telugu we'll call Neno Oka Vidyarthi. So initially it will predict Nenu. It doesn't have knowledge of Oka and Vidyarthi. So we need to mask this, right? That's why we'll be having what is called look ahead mask. So we are not looking ahead. Let me clear this ink. So initially, suppose our decoder, we are sending start of sentence token. So we have, let us assume our decoder size to be of length 5, x4 and x5. So we do not have knowledge of x2, x3, x4 and x5 initially. So let us keep this as zeros, or you can also keep 1e minus 6, okay. So these are zeros, right? Okay, we'll predict one output. Let us take the output as Nino. Now we'll be giving start of sentence as well as Nino to the decoder. We have no knowledge of x3, x4 and x5. So we'll be putting these as zeros. Again we'll get an output which is Oka. So we'll get SOS Nino Oka. We have no knowledge of x4 and x5. We'll be putting zeros. And we finally predict the output Nenu Oka Vidyarthi. Okay, and this is 0. And at the end, our model predicts end of sentence token. So here we'll be having end of sentence. So if you observe that these zeros follow a triangular matrix, upper triangular matrix. So simply our look ahead mask is a lower triangular matrix with all the ones. This is about look ahead mask. Okay, now let's move to the compiler in order to code all this stuff. Okay, I'm back into my compiler. So I'll be coding it in TensorFlow. Let me first import TensorFlow and also connect the. Now you can see that my runtime has been connected. Let me click on run button. You can also do it by shift enter. So this has been executed successfully. Let me take a sequence like 1, 2, 3, and 4, and also 0, comma 0. So we are implementing padding here. Let me show you padding. So we are implementing padding mask. So how you can do that? One thing is iterating through A. For I in A, if I double is equals to 0, so we'll be masking it. This is one way, but you can also do it using TensorFlow. In TensorFlow we have a function which is tf.math.equal. So what is this? TensorFlow has a module which is called math, and it has a function which is called equal. So whenever you are sending a sequence and you want to equal it to 0, so it will just show you the output where the values are 0. So initially see tf.mat.equal, and if I run this, I'll get false, 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 true, and true. So wherever there is 0, it will give me true. But I want to convert it into integer type. So you can use tf.cast. So what tf.cast does? It will convert into the data type you want to convert. Like if I want to convert into float, I can write data type is float32. And if I run this, I'll get an array of 0, 0, 0, 0, and 1, 1. Suppose I want to equal it to 1. I can do the same thing. So 1 followed by zeros. So this is the basic step. We are equaling it to 0. So we got the array. Let us take it as answer is equals to this one. And what we are doing, we are multiplying answer with 1e minus 6. And let me print the answer. So you got 1e minus 6 at the position 0. Now we are adding it to sequence. So you are adding a plus is equals to answer, and we are printing a. So you'll get 1, 2, 3, 4, and 1e minus 6 and 1e minus 6. Okay, this is about padding. Let us create a layer of padding. So for that, we'll be creating a class which is called padding mask. Padding mask. So as I told you, we are creating a layer in TensorFlow. So in order to create a layer, we need to inherit the layer. So tf dot keras dot layers dot layer. So whenever you are inheriting this tf dot keras dot layer dot layer, you can use it as a layer, as you usually use dense, max pooling. So you can also use the padding mask as you use them. Okay. Let me create init function and write the super statement padding mask comma self dot init. Okay, so whenever you are creating a layer, you need to initialize the layer as well as you need to create a function which is called call. So whenever you create the instance of this layer and whenever you call it, this function will be executed. And the advantage of TensorFlow is you need not to call this function explicitly. I'll be showing you how to call this. Okay, for now just write a sequence. See, here we are accepting a sequence. See, here we are accepting a sequence, and what we are doing, we are just implementing this function, right? Let me copy this and let me paste it over here. So instead of a, you can use sequence. So let me return the statement return tf dot and run this. Suppose I'm creating a class, I'm creating the instance of this class padding mask. Okay, and I'm calling the function. I'm giving the sequence here like 1, 2, 3, and 0. And if I execute the statement, I'll be getting 0, 0, 0, and 1. See here we haven't called the call function explicitly, but whenever you are passing the arguments, the TensorFlow framework itself calls the function call. Okay, this is what happens. Suppose I give an extra argument. If I give an extra argument, I get error because call function does not take more than two arguments, so it's by default calling the function call. So, okay, let me execute the statement. I got 0, 0, 0 and 1. But in reality, our TensorFlow framework accepts the data which is in the form number of training examples to this. Let us assume the number of training examples to be m, and it will accept the max sequence length. Max sequence length. So it is of two-dimensional array. So let me give you two-dimensional array and let me execute the statement. So I'm getting it as 0, 0, 0, 0 and 1. Okay, so we are passing a two-dimensional array and we are getting a two-dimensional array, but I want to modify this. I'll be explaining you why we are modifying it. See, I'm creating a new axis and I'm returning it. So whenever I create a new axis, I'm getting it in the shape of 1. Initially, when I do not execute this step, I'm getting the shape as 1 by 5. So when I'm creating a new dimension, I'm getting the shape as 1 comma 1 comma 5. So just simply remember that whenever we are adding tf dot new axis, at that position a new axis will be created. So that's it for this. You will be understanding why we are doing in the later videos. Okay, now let us create a look ahead mask. As I already told you, look ahead mask is simply just a triangular matrix. So let me create the look ahead mask. Look ahead mask. So for that, you can directly see our look ahead mask was 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, and so on. So you can directly use the function which is tf dot linear arg dot band part. So you can directly use this function. If you are using this function for more information, you can also see the documentation of this. But for now, just remember that whenever we are using this function, we'll be getting a triangular matrix. So we need to get the triangular matrix with ones. So that's why we are using tf dot ones. Our shape will be 1 comma max sequence length. So for in our case, max sequence length, let us assume it is 5. So max sequence length comma max sequence length. So why we are giving 5 by 5 here? Because we are expecting it to be a square matrix, right? So we are writing 5 by 5, and why we are writing 1 here? See, as I already told you, TensorFlow framework accepts number of training examples. So we have given an extra dimension. Okay, and now we need to add the lower limit, which is -1 and 0. So if I execute the statement, see I got a lower triangular matrix with ones. So this is about look ahead mask. Let me create a layer of look ahead mask. Let me write class look ahead mask, and I'm creating a layer class. So I'm inheriting Kira's layers, the same step which we have done earlier. So remember this step we'll be using in the whole TensorFlow playlist. So I'm creating an init method. It takes nothing. I'm inheriting. Okay, I'm writing the super method and I'm initializing it. So what arguments it is taking? It is just taking the maximum sequence length, right? So let me write it as max sequence length. So what we are doing, we are returning this. Let me copy this and just paste it over here. I am returning tf.1. Instead of 5, we need to write sorry, max sequence length, and let me run the statement. Let me create an instance of this look ahead mask. I created the instance of look ahead mask. Let me run this. See, I got object located at this location. So let me call this. I'm giving the maximum sequence length as 5. So I will get the same output as this. So this is about look ahead mask. In the next video we'll be discussing how to do positional encoding, and we'll be also creating an input layer encoder, decoder, and finally we'll be creating a transformer network architecture. That's it for this video. Thank you.